Hey, James.
Oh, here he is asking to take Jabber minutes. Whatever.
I'm going to ask him if he has any updates on the.
Okay. Yeah, that'd be great. Is he going to take minutes as well? Would you be able to take minutes as well? I think we have another minute taker, but if you can also.
We should probably start. Oh, Jabber. Okay, good.
Okay, good. Oh, okay.
So he's going to do Jabber.
James. Hello, everyone. This is Sixth Law Working Group. Welcome. I'm Samita Chakrabarti and Gabriel Montenegro. We are my co-chair. So Gabriel will start with the chair's slides on the agenda, and then we will have draft status.
Okay. So thanks for the volunteers, Zach on minute taking and James on Jabber. But if there's anybody else who's willing to go and help out, send us your minutes, that'd be great. So please don't be shy about that. Are we ready to? I can change it myself? Okay. So note well, I guess you all should know about this. Otherwise, then maybe it's time to leave. But everything here is under the auspices of the note well. We have a pretty full agenda. We have actually 3 screenfuls here of that. So I'm going to try to go on a fair clip here. Working group draft status since the last IETFs in Buenos Aires. We have a couple documents now in IESG processing at different stages. The DECT ULE document is, I guess, in the initial stages, and it's going through review by our esteemed AD. You want to comment on that, Suresh?
Yeah, so it's like waiting for an inter review. So I'm going to get an inter review done and along with the AD evaluation. And the other document is in, it's just finished IETF last call.
Right.
So the idea is to put it on a telechat on the 4th of August, the next telechat.
And the next telechat is in August?
4th of August, yeah.
4th of August,
yeah.
Excellent, okay.
And so after that, like there's a procedure for us to request an ether type from the IEEE. And so I'll go through the process once it goes through the IESG eval.
Okay, cool, thanks. We have some updates on a few documents that already went through last call. 6 flowback, the IANA registry document, and the paging dispatch document. I won't go into much detail here because we have discussions on those, presentations on those, so we'll see further details later on. Other working group crafts that we should keep an eye on include the backbone router document. Again, we're going to have a presentation on that. And then there's the mesh link, the MLE related documents, and there's not going to be a presentation this time around, but there's some ongoing conversations going with them, with the authors of that. So hopefully we'll have some more status update fairly soon to the working group. NFC as well, we are going to have a presentation today. Finally, there was a liaison statement from IEC JTC1, Working Group 10. It was about use cases in general. So given the fact that we also have a use cases activity going on, with those elements, we consulted with the IAB liaison manager, who happens to be our technical advisor, Rolf. And after he consulted or did whatever magic they do in the IAB, his comment was that for now, it doesn't seem necessary that we have a formal IETF liaison in response to their liaison statements. We can continue to accept liaison statements expressing interest of different items, and we can continue processing them informally. Of course, if something starts to change in terms of scope of work, we may revisit that. But for now, it seems like an informal relationship is okay. So we will continue to respond to them like we have been so far. And the current activity, you know, we have a good mirror here, so we have, I guess, good exchange of information going back and forth. Okay, anybody want to comment on that? It seems, yeah, okay. Okay, so now we're on to the first presentation of the day. We're going to have Carlos talking about Bluetooth LE mesh networks. Carlos, I guess, is going first because you need to zip out real quickly, right? You have some other, yeah, so, great, go ahead.
Good morning, everyone. I'm Carlos Gomez, and I'm going to present this revision of the draft entitled IPv6 over Bluetooth Low Energy Mesh Networks. My co-authors are Sayed Mahdi Darudi, also from UPC NITUCAT like myself, and Teemu Savolainen from Nokia. Okay, so first let's take a look at the motivation for this draft. Today we are witnessing that there is a high momentum of Bluetooth Low Energy or Bluetooth Smart technology, which is probably the main low power wireless technology deployed currently in smartphones, wearables, tablets, and similar consumer electronics devices. So Bluetooth Low Energy was first specified in Bluetooth 4.0, which only allows to create star topology networks. Then in a subsequent update in Bluetooth 4.1, then it's possible to have extended topologies. And this has attracted the interest, for example, of the industry, especially in the smart home area. So on the other hand, we have the RFC 7668, which was recently published, which defines IPv6 over Bluetooth Low Energy. However, this document was designed and optimized for a star topology network and actually would fail to enable IPv6 over a BLE mesh network. So this is what motivates this draft that I'm presenting today. So about the status of the document, the initial version of it was presented in Yokohama. And by the way, the approach in this document has always been to make use of existing Bluetooth specifications, such as Bluetooth 4.1 and the Internet Protocol Support Profile. So the idea is that we don't actually need new specifications from the Bluetooth Special Interest Group. And on the other hand, to reuse RFC 7668 whenever possible and suitable. And in version 0.0, there were a few TBDs left, a few gaps, and the latest revision, 0.1, intends to complete these gaps. So let's review which are the gaps that have been completed. So first of all, there's section 332, which focuses on neighbor discovery. Here we have added that the router behavior for 6LRs and 6LBRs is actually the one which is available in RFC 6775, that's the 6-LoWPAN neighbor discovery document, section 6. However, in this specification, there is one difference in this draft. There's one difference compared with RFC 6775, because we state that routers shall not use multicast NS messages to discover other routers layer addresses. That's because there's actually a problem with multicast in Bluetooth Low Energy. I'll refer to that in the next slide. However, we can still use the other approaches explained in RFC 6775, such as that sometimes the routing protocol already provides this kind of information. And also, it's always, well, the recommended method in RFC 6775 is the use of the address registration option. And on the other hand, we also reuse RFC 6775 with regard to the border router behavior. Then in section 334, which focuses on multicast mapping, we have a problem, which is that BLE link layer doesn't actually support multicast in a nice way, let's say. It means that if one node wants to multicast something to n neighboring nodes, this node has to actually unicast n times the same packet, which is possibly an issue, for instance, in terms of energy conservation. And therefore, we indicate that a router must keep track of neighboring multicast listeners and must not actually forward multicast packets to those neighbors which haven't registered as listeners for the multicast groups that the packets are intended to. Then we have also added content to the security considerations section. First of all, the same security considerations in RFC 7668 still apply. But then, since now we need a routing protocol for finding the routes in the mesh network, then this is opening the door to additional opportunities for threats and attacks. So we explain in this section that there's a document which is RFC 7416, which provides a systematic overview of threats and attacks on the Ripple protocol. So this guidance is useful, for instance, if Ripple is the routing protocol chosen for this mesh network. And it could also be probably partially useful if the routing protocol is another one. And I'd like to remark that in this document, we don't state which should be the routing protocol. We leave this as something that can be freely chosen. So in addition, we have applied some minor editorial updates, corrected a few typos, updated a few references, and cleaned the references section so that it's now in good shape. So at this moment, as we consider that the gaps are completed, we are wondering whether the document would be ready for working group adoption. So this is what we'd like to ask to the chairs and to the working group.
Anyone has read this document? Okay, so 3 or 4 people. May I ask you, Carlos, do you know what is the position in Bluetooth SIG about this document? Are they aware of this work?
I think they are aware. I don't know which is their position, but we have contacts so that we can ask them which is their opinion about this work, if you think this is...
Yeah, I think that would be good to have some awareness in the Bluetooth SIG. And so do people generally think that this kind of solution is interesting? Can you harm? Okay. So we have some good response.
I do have one question. There is, Don Sturek, Silver Spring Network. So I do have one question. So there is one case where you can't get around multicast if you haven't replaced the router solicitation and the router advertisements. Do you have a way of doing prefix delegation in Bluetooth in your whatever routing protocol you're using to avoid that?
I assume we could include that. So far we are not considering this, but we could possibly think about ways to.
That's the one case where you have to do multicast in 6775 unless you've replaced it.
Okay.
Ari Keränen, Ericsson. What is the relationship of this work and the mesh work at the Bluetooth SIG?
Yeah, that's a good question. Actually, I'm not a member of the Bluetooth Special Interest Group, and also I think what's going on in the Bluetooth SIG is close to those members, and it's not publicly available. So I actually only know what is published in, let's say, the magazines, but that's kind of unofficial information and not really details on what's going on. It might be that they might be using some other different mechanisms for allowing some kind of multi-hop communication. However, our position on this is that by adding a little more to RFC 7668, we can enable IPv6 over a Bluetooth Low Energy mesh. So we don't actually need new work from Bluetooth SIG to enable this, we believe. And yeah, anyway, it would be good to know what are they doing, what are they developing, and to see, I don't know, if there's any kind of problem. I understand that as we actually don't need new specifications from them, this shouldn't actually harm in any way the work they might be doing, because this is actually extending the applicability of what we already have in RFC 7668. However, yeah, it would be good to know their opinion, so I think it would be good to contact Bluetooth SIG and know a bit more of their position regarding this document.
Okay, I think something like that is definitely needed because we don't want to have it in competing solutions here. So I think before we go anything like working group adoption or anywhere near that, I think we should clarify that part. Like what are different organizations doing and what's the relationship there?
Yeah, I totally agree. Nevertheless, I fear that it might happen that maybe what they are doing might end up being not compatible even with IP. So let's see what happens.
So, Dave Taylor, the split is supposed to be that this group does IP over it, and that group does it without defining the IP over it part. So whatever they define, but they don't touch IP, right? And then we say, whatever that is, we can't modify, and we have to say how you can possibly run IP over it. So that's the division of labor.
That's Dave Taylor. So, Suresh Krishnan, one thing, so we had a chat about this at the IESG retreat. So we met actually somebody from the Bluetooth SIG, but Dave might correct me, but I don't think we have an official liaison relationship to them. So there's no official way of sending something to them. And I think it's got something to do with their IPR policy, or the membership policy that kind of makes it difficult for us to do that. Okay, so it needs to happen through some kind of participants, doing some kind of back channel communication to make this work. So I agree with Ari's point, we shouldn't step over the toes, but I don't think we are. Okay, so when I actually specifically talked about this, they said they were not doing IPv6 work on top of this, just like Dave said. But if there's I have a name of a person, we can shoot off a mail to him about this draft and see if anything comes back as a negative, but there's no official relationship.
A question, now that you're up there. So would you think it's okay for us to start, for example, working with Blast Call in parallel to finding out what Bluetooth SIG is doing and use that to inform what we should do? It may, I'm not clear that we are binding to what they will have to say if we are completely independent, as we think we are. But should we use it in parallel? as part of the information.
You said last call, like no, right? Like, but if it's adoption call.
I'm sorry,
go ahead.
adoption, sorry.
So
adoption.
I think before last call, I think we should start
No,
with
no,
the adoption call.
I meant adoption, yeah. So an adoption, basically what I'm saying is we don't need to wait until we resolve those stuff to work on working with adoption,
Right, and
correct?
if they come back and say like, we're working on it, we should be prepared to drop it. So I think it's okay.
Okay. That's-
Yep, Dave Taylor. So I agree. I don't think that there's any reason that we should wait for working group adoption. I think
Okay.
that having IPv6 over Bluetooth mesh is something that I hope that we all want, just like we want IPv6 over just about everything else that this working group is doing, right? And so I don't think there's any reason to delay an adoption call. I think what is important is just that we get Bluetooth SIG people reviewing the document before it goes into last call, and so we make sure that the technologies are compatible, because this is a layer over that, and we want to make sure that they work well together as one coherent unit. But I don't think that should hold up adoption. I think they should be adopted. So thank you.
Thank you. So we could see that people have interest, and you will follow up with Bluetooth SIG. We will also help you with that. And then we will take it up to the mailing list. And I think more people need to read and review this document before we ask for adoption call. Okay, thanks. Katie? Would you like to take this?
Good morning. My name is Kerry Lynn. We have a full schedule, and many of you have been hearing this talk for 5 years, so I'll try to keep it brief. This is about a proposal called 6 low back, which is for constrained networks that run over RS-485. So here's the motivation. The building controls industry is moving towards IPv6. It's a very slow-moving and conservative body or discipline. This proposal basically covers the case of the most numerous and least costly devices in such a network, and is the primary use case is basically as a field bus between an area controller and the leaf nodes, like all of the error handlers that are in a room like this. The basic MAC is token passing. The thing that's interesting from an implementation standpoint is that it's all done on the metal, so it's all done in software. So there are basically 2 standards that pertain to this. The MAC layer is defined by BACnet, which is the International Open Standard for Building Control, and it's MSTP. That work is all done. Basically there we did work to make the packet payloads larger, so fragmentation is not necessary over this data link. Basically we tried to leverage as much as we could from the 6LoW specifications. The bottom line is that the only thing that we're really doing here with the encapsulation is data compression, header compression. So the proposal has been through last call. As the chairs reported, it's ready to go to IESG. There's 2 interoperable implementations that have been tested against each other at the 6LoW plug test in Yokohama. The results from that were very good. There's also a Wireshark dissector available. We're hoping to upstream that code in parallel with the IESG review. As I said, there's no external dependencies. Everything is resolved. And we have 3 detailed reviews. So I want to thank Peter Vanderstock, James Woodyett, and Karsten for doing those reviews. The changes since the last edition were primarily editorial based on Karsten's input. Quickest thing is to just, go to tools and look at the diffs, tools. The one possible point of contention as we go to IESG review is that this draft is recommending the use of link layer derived addresses for local traffic so that we can take maximum advantage of the header compression. But it recommends privacy addresses for all routable addresses. So that's kind of an intro to Dave's talk coming up. And that's it. So if this draft is new to you and you have any questions about it, please come and see me during the week or send me email, and I'd be happy to answer your questions. Thank you.
Thank you, Katie. Yeah, we will submit to ISG pretty soon. Next is Dave.
Just look behind me to find the slides, right? Okay, so this is draft 01 of the privacy considerations document. Next slide. All right, so as a reminder, if you're new to this, the purpose of this document is to talk to people who write documents, not people who write code. Okay, the people who write documents specifically in this working group and in any future derivations of IPv6 over food, but primarily for constrained nodes. So the key message is to tell people what issues to discuss in the privacy consideration section or security consideration section, depending on what type of section you have in the document. Okay, so this is the point is to say, here are some issues that you need to address. There's nothing in here that says you must do X. It's here are the set of issues you must contain a discussion of or reference something that answers them for you, or you should expect to discuss from the IESG. All right, so that's the context. Okay, next slide. So these are my personal points that motivated some of the text that's in here, but these statements are not in the document. And so if you disagree with them, you can't disagree with what's in the document because the document doesn't say these things. Okay? But these do motivate some of the things that are in there. And so you will expect me to respond with these points if you comment on later things that might affect these. So first of all, my belief is that any IP over foo protocol should be designed without limiting what the upper layer protocols are that can run over it. Okay, and of course this is whenever possible, right? If you're designing something that does not support multicast or broadcast, then that might be limiting what types of upper layer protocols can possibly run over it at least efficiently. You're just making them to do workarounds, that sort of thing. Yes, of course, that part is fine, right? It's just they should try to be agnostic of the upper layer protocol, right? That's good layer separation. And then secondly, a IP over foo protocol shouldn't assume that there has to always be some firewall thing. Of course, that may mean that there's some privacy issues, that a firewall in some situations may be deployed in order to mitigate those concerns. Okay? But you can't just assume that there's going to be a firewall every place. I guess my belief maybe for the what's the special session that we're having with a Japanese name? Anyway, is that a firewall is often evidence that there's some protocol design issue someplace else. But all right, let's move on. Okay, so now let me get to actually in the document. Okay, because all of my slides here, thank you, Carrie, for doing a thorough review. And so all these are sort of touching on things that were that came up in Carrie's review. So there's 4 points there that were just done. If you haven't seen those. Address scanning, okay, Carrie pointed out that address scanning is not terribly important for link local addresses because if you are on link, then you can see the stuff anyway, right? Address scanning is a concern for routable addresses, okay? And so all the text that talked about you need a bunch of bits of entropy to mitigate address scans, the text now makes it clear that that text about address scanning doesn't really apply to link locals, it applies to routable addresses. It distinguishes between which issues are relevant to on-link attackers versus off-link attackers, which the original text often didn't make a strong distinction between them, and that's cleaned up. The number 46 was used as an example, and so I tried to reduce the number of places that was quoted because that is an example that says, based on the link lifetime, you compute how many bits of entropy that you need for routable addresses. This was kind of from an example where your link lifetime was at least 8 years. Okay, so if you have if your link could be up for at least 8 years with hosts, coming and going or stable, like in a factory network or something like that, then this is the number of bits that would pop out at the end of that equation. Okay, but there's nothing magic about that. Just like there's nothing magic about the 8-year number. The point is, if you're doing NFC for a tap or whatever it is, you can say the maximum link lifetime is such and such, and therefore the number of bits of entropy that I need in a routable address is Y using the equation. and then various minor editorial fixes and corrections that Carrie pointed out. There are two things that I did not make changes for, other than I responded in the email thread. And so I wanted to call those out here. And then I have, I think, 3 or so slides after this one on specific text that I wanted some discussion on. Okay, so these 2 points. Carrie pointed out that the terms EUI 64 and EUI 48 are trademarked. And I think he suggested that the document note that fact. And I went around and looked at other RFCs that reference EUI 64 and 48 and noted that none of them mentioned that they were trademarked. And so I chose to just be consistent with the other ones and not mention this. If you think that's a problem, let me know. But I said if it was a problem, it would have been a problem for all the other RFCs. So I consider that one to be not as important as the other ones that I fixed. Then Carrie suggested a specific phrase here that I explained why I didn't like that particular phrase. The phrase that was suggested was privacy IIDs are recommended for routable addresses, and Carrie's emphasis is on the word routable here, which was taken, okay, in many places. But the rest of it, I mentioned, the notion of privacy IIDs is a term that isn't defined, and I didn't want to define it. And an example is, if a lifetime is less than 1 second, then doing something more complex might be overkill. And so I didn't think there was working group consensus on trying to say what was recommended. I think the main point of the document was to say you should be able to mitigate the concerns given the link lifetime. Okay, so I didn't pull in the stronger statement about recommended in all cases. I said you should be able to derive that from yourself. So those are the only 2 things that I did not make any changes to specifically address. And then we'll go through the next couple slides here. Next slide. Okay. So on the topic of link local addresses, which was probably the biggest category of topics that was in Carrie's review, okay, here's one of 2 pieces of text that I did not make a change to and wanted to have discussion or at least head nodding or head shaking or whatever on. Okay, so here's what the document actually said on this bullet. It said specifications should not simply construct an IPv6 interface identifier by padding a short address with a set of other well-known constant bits unless the link lifetime is guaranteed to be extremely short. Okay, and so Carrie pointed out that there's nothing in this sentence that uses the word routable or link local. It's implied to be general, to apply to all interface identifiers and all addresses. And so the question is, does this need some change, or is it okay this way? Okay, because Carrie said, well, this probably doesn't apply to link locals, right? And so when we go through the list of threats in the privacy addresses RFC, or the privacy considerations RFC in 6-man, there's 4 of them, of which 3 of them I agree are not really applicable. Okay, correlation over time, that's if you change it now and then. This has nothing to do with how often you change the address. Right? Vulnerability fingerprinting and address scanning, which was Carrie's main point there, that this address scanning does not really motivate this. But the one that is the most relevant is location tracking, okay? And so if I'm using the same stable identifier, like a MAC address-like thing as I move between networks, then there's an issue if that MAC address or link layer address has enough bits. So for example, if you have millions and millions of deployments and you have 8-bit numbers, then your anonymity set, in other words, your number out of that 8 bits, is the same as a lot of other people's. And that's probably fine. But if your link layer address is, let's say, 24 bits, and there's 2 million in existence, then there is still an issue to take those 24 bits and pad them, okay? Because those 24 bits are sufficient to enable location tracking as that entity moves between, say, 2 networks that are being monitored by an attacker, okay? So my claim is that that point still applies to link local addresses. If the short address is unique enough. In other words, if your short address isn't all that short. Okay. So that's my intent. And the question is this text good enough, or can you actually suggest a way to improve this given that point? If no one has a suggestion, then I will keep it as is, but I think this is the main point that I wanted to get across. Maybe I will take a shot if nobody else has something to find a way of phrasing the part that's in bold there. But any wording suggestions accepted, but that's the bolded sentence there is what I might try to find a way to add a sentence for. I see Suresh nodding. Okay. Okay.
Question on this. explanation in here about the different attacks, and which one actually does apply. Is that in the document, in the draft?
The list of those 4 is in the beginning of the draft, yes.
But I mean, for this particular point in particular?
Right. This particular point, along with some other ones, comes from the recommendation section, which is more or less the conclusions.
Well, my question is, you have the text you have there does not mention why.
Right.
So if you
that's
just say, for the point of view of
Exactly.
location tracking, which is the only applicable up of
Right,
section
right.
whatever, then that's why we have this, something like to tie that together might
Correct.
help.
That's why I bolded the term location tracking : as well. So the whole bolded point is what I would try to find some way of phrasing in a sentence.
Okay, good.
And of
Yeah.
course, using because of location tracking or whatever, and unique enough. And I would leave it to the authors of the document of a document in question to argue what is unique enough along the short address, right? So those who just say, well, my document has only 8 bits, and so location tracking is not an issue, that would be a sufficient statement. If it says, well, my thing has 24 or 48 or whatever, then you have to argue why that's okay. All right, Kerry.
Kerry Lynn, Verizon Labs. So I'm not sure I agree that this is still, that this is an issue, because in cases where short addresses are being used, that they're typically handed out by some sort of a network controller. And then there are other cases like wired networks where you never leave the link. So you're either, sending traffic or not.
Yeah, so I would try to capture in here, because it wasn't on the slide, but I said it verbally, which is the stable notion, that is if you're using the same link layer address across different networks, right? That's the assumption here, is to say if it was, and I think I used the word stable before, just because I think that's the word that Fernando uses in the other document.
I guess my point is, if these short addresses are being allocated to L2, then you cannot be certain if you leave the link and come back that it hasn't been allocated to another node in the meantime.
Right. Your point is that
An attacker
if
can't
the
assume.
short address is allocated by the network, then it doesn't fit into the stable category. And this sentence is about ones that are preserved across them, right? So I need to make sure that we find a way to do that. Is you could say a way of mitigating this is sort of inherent in some of these mechanisms. It says if it is allocated on a per network basis, then this is not an issue. Yeah. Okay. Good point. Hopefully the note taker has captured that, so I make sure I don't forget it.
Answer Krishnan. So if I understand correctly, Dave, right? Like, so Kerry just stating that in the RC or the draft would like take care of a requirement, right? Of doing that, saying like this short ID is allocated by the network, so it's not relevant.
Right.
So that should be like one way of handling it, right?
Yep. Absolutely. Okay, let's move on to the next one. Okay, so this is the, I think this is the bullet that immediately comes after the previous one, and it has a similar thing in it. Says specifications should make sure that an IPv6 address, okay, note so far this one does not contain a distinction of link local or routable or anything else, should make sure that it can change over long periods of time. For example, the interface identifier might change each time a device connects to the network, right, which was Kerry's point just now, if connections are short, or might change each day if connections can be long. Again, those are just examples with the word might. This is necessary to mitigate correlation over time. So the question here is, well, does this apply to link local addresses or not? Okay. And this actually comes back to the discussion of on-link versus off-link attackers and how important link local addresses are. And so what I had said in the email thread was, my belief is that it still applies, it just applies less. Okay. And so for on-link attackers, if you change the link layer address to, so for example, your link local address is derived from your link layer address, and you change them both because one is derived from the other, then that is a way of addressing this, absolutely. For off-link attackers, okay, which is probably the bigger, more likely threat, it applies if and only if link local addresses can leak outside that link within a higher layer protocol. Now, my belief from observation, this is pointed out in the 6-man documents, is that it is known from observation that this does happen, even though it would be a really bad idea to do so. It happens by accident a lot. A lot of protocols that are upper layer protocols leak stuff, SMTP, SIP, DNS, and so on. Okay. The and so on includes, vendor-specific protocol A, B, or C, right? And so this one actually goes back to the point of when designing an IP over food protocol, right? Do you want to make any constraints or assumptions about what the upper layer protocols do that may go all the way up into vendor-specific application layer protocols. Right. So my belief is that it is important to not assume that they won't leak. It will just be less common. Okay. And so that some mitigation should be covered in the document. By the document, meaning the specification that's an IP over food document, to have an argument that says, oh, gee, this will never happen, and then the IESG will evaluate whether they actually believe that. Okay. Kerry.
Kerry Lynn, Verizon Labs. So I do agree that this last bullet is potentially a hole, but I think it's an education problem, just like buffer overflow attacks were an education problem. And so I guess from your perspective, would you like to see a proposal contain a line in the security section saying, you know, it's, we recommend that application developers are very careful not to leak link layer addresses when using this data link?
You asked what I would like. Okay, so I would like a pony, but I fully expect that application developers will never read any of these RFCs. They're like way too many layers up. And so anything that you say in an IP over food document will never be read by the class of people that this would be targeting, that such a problem that you're suggesting would be targeting. So what I would like is I would like the protocol to be robust, to make it more difficult if and when things do leak. I just call that defense in depth, right? If you assume that something bad is going to happen sooner or later, you should be prepared to deal with that. It's not going to be nearly as common, right? And so it doesn't have to be as strong of a mitigation, okay? But there should be something. Worst case, you could say, this is a job of a firewall for you to put it in front of there and do content inspection. Now, my belief is, of course, that that is a bad design, okay, and that you shouldn't have to do that. But the point is that this is a style of thing that should be covered in the privacy consideration section. Okay. So what I would like is I would like the protocol to have sufficient entropy and link local addresses, or some other equivalent mitigation if it's not entropy, you know, short lifetime or whatever it is. Okay. So this one, I don't have anything in bold, okay? So I don't know of a reason that I would change something here unless somebody suggests that. Did you have a comment? You're next.
Yes, one comment.
State your name.
Benedict Stockerbrands, Tabletter IT. Yesterday we had the presentation from what's going on in IEEE 802, and they are working on changing the link layer addresses. So if we don't put that in there, basically we make their efforts futile, on basically, well, we don't do our part of the job. We should really see that we can deal with changing link layer addresses and do the changes in the link local addresses as well.
Yes, one way of changing link local addresses is to change the link layer address and then derive the link local from the link layer. Absolutely, right? That is just one way of accomplishing this. It's not the only way of accomplishing this, because some of the other mechanisms have no link layer, necessarily have no link layer address from which the IPv6 addresses are derived, and so on. So there's multiple ways of doing it, but that's obviously a prominent one being discussed now. Yeah. Okay. If there's no other discussion, I have, I think, one last slide, if I remember right. This is it. Okay. So the last suggestion that Kerry made that I have not acted on yet, and I mentioned on the mailing list that I was going to bring this up in the meeting, so here it is. There was a suggestion that should we mention something about using DHCP-v6 to get privacy addresses, or temporary addresses, I think was the actual term. And originally I said I couldn't find anything to reference. And then finally, after the internet draft deadline, I found something. And what I found is this discussion, which is 7824. And this is the actual text quoted from that RFC. And so the question is, should we say something or should we not say something? Right now, and I'll point out what's in here in a second here, but you can read now that I'm stalling. Right now, my inclination is to continue to say nothing in this document, but if you believe that we should say something, let me know. This document is talking about some operational issues that result in nobody using DHCP-v6, it claims, for temporary addresses right now. And the main issue is that it says that 4704 does not explicitly prohibit servers, this is DHCP servers, from updating DNS for assigned temporary addresses, right? And so if a client doesn't know whether the server is going to register it or not, it can't safely use it because it may not be terribly private if it does use it, right? And so I see the chair of the DHG working group standing at the mic, and so I'll let him weigh in. Go ahead.
Former chair. This is Ralph Drums. So I guess you answered one of my questions as you were speaking, which is when you initially said, should we say anything? I was going to ask to whom about what. The reason I asked that is the second point I was going to make, which is there's an effort in the DHC working group right now to publish an RFC 3315 bis. I don't know if you're aware of that or not, and whether or not this might be interesting information to pass into that effort. If you think it is, please do. That effort's actually almost completed. I'm going to be the document shepherd for it, so it's going to go into working group last call fairly soon. And I think those were basically the two questions. So
Okay,
thank
so
you.
the very first slide after the title slide, I mentioned that the primary audience for this was people writing specs that are IP over foo specs. And so is there anything that we want a IP over foo spec author to know about?
Okay.
And the question here, the suggestion here that Carrie had suggestion was, when telling people what to put in their security or privacy consideration section about, how to use temporary addresses and so on to mitigate correlation over time, right? Perhaps this is a way to have a mitigation. If you can say, well, you could potentially use, Slack with the 4941 or whatever it is, or you could use DHCP such and such and point to that. Okay, if there's something we want to say there that, gee, you could put this in as a potential mitigation. Okay. After I found this, I'm thinking maybe we don't want to give that advice yet.
Okay, great. That's just the answer I wanted to hear. But if you would pass that along, or if you want me to pass that conflict, in particular, this sort of technical conflict between can be renewed, but there's no way to renew them.
Why don't you pass it along? Since I think this RFC that I'm quoting came from your working group.
Oh, okay.
So yes, I'm a co-author of that RFC. There's also another one that's a 7844. That's the anonymity profile, right? And
Yes, I did check that one before sending that email, and there's nothing in there that's relevant to this particular point. That one is the one that you're talking about is what a client should or should not put in its DHCP request to keep anonymity away from the from the network. Okay, that
right.
one doesn't affect this particular threat.
yeah, so one of the things is like, don't use the temporary addresses, right? Like the IETF stuff. So I think it's kind of related, but not like, so I think this is sufficient, but I think if you don't want to pass on the information, I can do that to the 3315 bis people. Okay.
Okay. Juan Carlos Zúñiga, Sigfox. Regarding the concern about what's happening in IEEE 802, and I think it's a valid point, it's worth mentioning that this is not isolated. There's things happening in 6-man, there's things happening in IEEE 802, and we have to look at the whole picture because otherwise we don't have a full answer to the questions, or we are not doing our work as we should. I don't know if that's something we should mention in the document so that it's obvious for readers actually, so that they understand that there's things to take into account. But just wanted to mention this in the mic for people that are not necessarily aware of what's going on in 6-man or in IEEE 802.
Okay, thank you. If I remember correctly, there is a mention right now in there about Christian Wittema's document on the implications of link layer randomization. I don't remember what the title is. There's a title something like that, and I believe that one is his document covers IEEE and other organizations that are looking at doing this, and this one just references his document, which I think is just an internet draft right now. So I believe I put in an informative reference to his document that says, and link layer randomization can be, fuller discussion can be found in such and such. So I think it's there by proxy right now.
Tim Winters, UNHIOL. So the DHCP 3315 biz. What it says now about IETAs is that it's not recommended to try to renew them. So I think we're okay here going forward. So I think we're good on that part. I don't think there's any actual feedback. That's what it says right now.
Okay.
Carrie Lynn, maybe this is just a misunderstanding on my part, but I think there's a related question, which is what if you receive an RA that says, that has the N bit set to 1 and says you should, use DHCP for your address assignments? Maybe I just don't sort of understand how that works.
That's not what the MBIT says. That's
Right,
a 6-man discussion. The MBIT says that there's DHCP server available. It doesn't say what you're supposed to use. That's a client decision. So that one I think is out of scope for this group.
Yeah, exactly. It's like that's Suresh Krishnan again. Like, so yeah, that's what I want to say. Like, it's informational. It's not mandatory. And we never managed over the last 15 years to do anything about it.
Yeah, Samita Chakrabarti. Just a follow-up question to this IEEE recent changes. Is there a document that we can point to? Maybe then we should have a direct reference to that document on the IEEE.
I believe I already do. So I either point to Christian's document and or another document, I don't remember, but I remember adding text into this, not in 01, but in 00. Sorry, the working group draft is 00, not the, I mean, after we adopted it, I think it was in that one. All right, thank you. So last slide.
Okay. So next, I guess, Samita, right?
So at least make a change for the bolded part, and then my belief is that all things have been raised, unless somebody raises a new comment, I'll ask for working group last call after doing that.
Yeah, seems reasonable.
Okay, so this is about the 6-slow dispatch escape byte document that we started almost a year ago. And it went to the last call, and the reason for starting this document is, is from the request from ITUT on using certain code points, and we wanted to register with the IANA. But while we are doing the work, we thought, we got a request from the working group to define some of those behavior of using escape bytes. So once we did that, so it went to last call, and we have a new shepherd. Brian kindly agreed to shepherd this document, and we got really valuable comments. So one of the things is the change in title. So originally our intention was to record those code points for IANA registry, but now that we also discussed the behavior of escape bytes and defined it, we wanted to represent the content by the title. So new title would be 6-slow escape dispatch code points and guidelines. It used to be previously IANA registry and 6-slow and escape bytes. And then we also are updating the abstract, also from the comments of the shepherd, that it updates RFC 4944 and 6282, and also registers the entries for the known use cases as of today. So that's pretty much the basic changes of the document. And then the two other changes are that we need to specify how when somebody requests for new IANA code points for the dispatch bytes, how an expert will assess those and make a decision whether that code point value is justified or not. So we need to, we have some guidelines in the document already, but we need to put some of these consolidated information into the INS section. And the fourth option is identify possible expert contacts. So we recommend, our proposed contacts are the 6-slow working group technical advisor and the working group chairs. So that's pretty much about the changes, and we are going to update those changes and submit the new draft this week. And then I think the authors believe that we are going to be ready for the next step, which is ESG submission. So any comments? Okay, thank you.
Next, Pascal.
Just give me a second. Yeah, I'll upload it.
Okay, so you'll remember the long story of the 6-low routing header. And the draft was finally split into the code dispatch and the page dispatch. The code dispatch stays at 6-low, and the routing dispatch goes to the routing area, actually at roll. And both drafts have passed last call. And Alvaro is now trying to move the 6-low average document across the ISG, but it's actually being held because of the code dispatch at 6-low, which is not yet submitted to the ISG. So the action right now is the Shepherd write-up, which should happen soon, I hope, Samita?
Yes, Gabriel, do you have updates from James?
James, you want to say anything?
This is James Whittier at Nest Labs. I have written some, but not all of the document Shepherd write-up. There are still some items in the document Shepherd write-up template that I don't have the answers to the questions that are in that template. So I'll be talking to the authors of the draft to fill in those gaps, and then it should be ready.
Thanks.
Okay, so Suresh Krishnan. So again, so if you don't think something is relevant there, feel free to leave it out. Okay, so and it doesn't have to be perfect. If it comes through and there's questions, you can probably update it later. But just go ahead, get it done, and get the document on the way. It's good if it's perfect, but if it's not, let's go with what we have.
Okay, so just for memory, this draft is just the piece that is updating 4944. And what it's redoing is setting that if the first 4 bits are 1, so it's very easy to actually see in a trace. If the first 4 bits are all 1s, so the 6-low pan dispatch starts with a fox, then the next 4 bits are page number. And from this page number, you can really have a whole new addressing space. It's being used by 6-low RH, but it's redesigned to be extensible for all sorts of uses. And there was a discussion about fragmentation yesterday where using this was proposed. So the last change is I republished it today because the Robert Craiggie's name was missing. That's the only change apart from renewal of the date. So that was done today. And that's it for this one. Questions?
Do you have a second document? Router, are you going to, is he,
Backbone
no,
router, yeah.
is he right now going to present that?
Yeah, he's right now.
Let's see routers.
So there are a good number of news for the backbone router draft. So as you remember, this was adopted early this year as a workgroup document. It is kind of a thick document because it really has 3 parts in it. One of them is descriptive, just explain what this thing is about. Second piece is an update of RFC 6775. And the last piece is the actually new protocol for enabling neighbor discovery proxy for all sorts of wireless devices. Mostly low power, but it could be extended to Wi-Fi and things like that. The news is that a few days ago, we have run a NetC plug test with 6-low and 6-dish. And one of the main items of that plug test was testing the backbone router. There were 2 implementations, one by Cisco actually, and the other one open source on OpenWRT. And we'll be reporting at 6-dish, but today as well about the results. The backbone router test passed around 66%, which means that a good number of the procedures passed.
we could see movement of devices across the backbone. We could see devices changing 6LBR, going from one 6LBR to another, the movement being correctly interpreted, and then we could see duplication and the rejection happening and the flows with the status, etc. happening. So that was really good. And this, last but not least, you know that for the last number of IETFs now, there has been a discussion between the IEEE and the IETF through the IETF IEEE coordination, which is meeting tomorrow morning. And the load of on the radio, on the Wi-Fi in particular, that is due to protocols such as neighbor discovery is actually one of the big items that are being discussed there. And this backbone router with the association, layer 3 association process that it proposes, which extends 6LoWPAN-ND, is actually a very interesting solution for the problem that is being discussed at the IEEE IETF coordination. So the news, and I'll be discussing that on the next set of slides as well, is we discussed with Eric and Samita and Gabriel, and we found that, like I said, this draft is too thick. That's too much stuff in there. In particular, it would be good to extract what is really the update of 6775 and make that a separate draft. And, well, I'll be discussing what we did there. But yes, this has happened. There is a personal submission about the piece of the backbone router which just extends, updates 6775 to enable the proxy registration of a device that is deep down in the mesh. And so that includes changing the register address from the source to the target and enabling movement from one 6LBR to the next 6LBR. And that is done through a sequence number that we call the TID. Just for memory, what is the backbone router in the first place? The backbone router is a way to isolate the broadcast domain from a backbone, which can be Ethernet and the radio piece of the network. So we do a form of proxy neighbor discovery between those. And how this proxy neighbor discovery happens is very similar to a registration Wi-Fi, but done at layer 3. So the IPv6 address is being announced to the backbone router, and the backbone router will defend that for a lifetime over the backbone. That's exactly what we've been seeing during the platform. Let's go to my chat. Any question?
Gabriel Montenegro, Microsoft. This might actually be more a question to Juan Carlos. So hopefully he's still in the room. Oh, there you go. What is the status, if any, from the IEEE point of view about this document? I think that would be good to know from the point of view of how important this is. Oh, okay. So my question was, this has been discussed within the topic of coordination between IEEE and IETF. So I wanted to know from IEEE's point of view, is there any dependency? What is the status, basically, of this document from the IEEE's point of view?
I'm not following that specific part, but you mean related to 802C or the link layer addressing or the?
No, the problem of the broadcast due to IP broadcast over the Wi-Fi medium. So the point that Dorothy is bringing up.
Okay.
This is actually, I talked to Dorothy several times, and this is actually a possible way to handle this particular problem.
Okay, so on that side, there is the discussion took place in the interior last time, and we are working on an update to that document, basically to capture all the actual solutions that we have right now to the multicast issue, and first of all to inform the community, and then hopefully provide recommendations. But it's on the work right now, and that would come out in the document in interior.
From what I understand, we're not being a gating item. We're not blocking any IEEE work.
No.
Yeah, this is one of the things they're looking at among others, but we're not necessarily on it.
Right.
Okay, so that's good to know.
It's a possible solution that we are putting on the table to help solve the problem that we have here, right?
And the idea, by the way, is is to make this, make people aware of this beyond just the 6-law community, because in IEEE, not everyone is aware of this. So it's a good idea to put it in that document.
Done with this one if you want to move to. Any more questions on the background router?
Actually, I have questions on the split of the document that you mentioned on the RFC 6775 update. I think you have another presentation after that. Okay.
Do you want to do it now, or do you want to do it later?
I think it's scheduled later, so maybe we can bring it up then how we want to proceed with that.
Right. So like I said, there are really 3 documents in one. So one of them is the update that is now split, but since the split is not adopted, I have not removed the text from this one. So this one is still in its original shape. And if we adopt the other one, then I remove the text, which is duplicate. Then there is all the descriptive part. You'll find that the first 10 pages maybe are pure text, explaining what we are doing, why we're doing, actually why it applies to IEEE problem, well, the IETF IEEE problem of broadcast. That text should not stay in this document in its final form, because it's not prescriptive text, it's just descriptive. And so my suggestion to the group is to agree on splitting not in 2, but actually in 3, so that we make a informal that really explains how the backbone router, the proxy operation works, what it does, why it's there, and just keep that informational, and just keep the behavior, the must, etc. in this document for the proxy operation, and put the registration operation as RFC 6775 update. You see, just to make 3 documents which are at their own homogeneity. That's my suggestion for these documents.
And talking about one of those 3 documents, the one that's more, the more informational one, do you think that deserves to live as a separate document, or is that feedback into this common document that is being done in TERIA effort? Is that a section in that document, for example?
Let's discuss. I've no
Possibility,
idea.
okay. Fine.
No idea. We need to discuss that on the mailing list, because we need to agree on what gets split and what goes.
Yeah, okay.
It would be good if you just put your suggestions on the mailing list.
I'll start with this, just split in 3, and then with Gabrielle, we'll look at proposal of what goes in front of the mailing list.
Thanks. Thank you, Pascal.
My name is Youngwan Choi from A3. This first slide is the quick introduction about the NFC. The point is the NFC, we use the P2P mode of the NFC for the IPv6 or NFC. The P2P mode means a little bit different from the common peer-to-peer mode we use for communication. In NFC, the P2P means just the direct connection between two devices in the link layer. This is history and status. This is the first update. We have the 3 updates is from Mr. Carter's comment. Thank you, Ms. Carter. The first one is about the simple multiple hop approach. Actually, there were 2 unclear the terms. We used the peer-to-peer topology, and the simple multiple topology is not relevant in this paragraph. So just we change like this the blue color sentence. And then there is one the characteristic of the NFC link layer. The NFC link layer does not support the mesh under, so just put about the information about here. The second is the fragmentation. Actually, in the first stage in this document, we consider the fragmentation in the IPv6 of NFC protocol. But next revision, we found just NFC link can be extended to the of MTU. So just we don't need the sentence anymore. So just like a little bit of the blue with line sentence. And the next one is typo. Just change it. It's minor. And the other, I have two things to announce to all of you. One is the sixth law protest. There was last week. Actually, in the previous, the first protest, we only passed two cases, test cases. There was under 20% passed it. But the protest, we passed over the 80%, the 10 test cases to of 12 cases. But just we checked the overall operation, but just we cannot use the packet dump program because there was some error. So in the sixth protest, maybe we will advance the checking the detailed feature by using the packet dump, and we will also pass the last of test cases we have this time. And the third one and first is kind of interoperability between with the other devices and the NFC chips. Just we have this time and the previous time, just we have just PN532 chipsets. And we have two kind of device. One is Intel Edison board from the Neo Reflection in Korea, and the other one is laptop, the Linux we used from A3. And that's all. And next one is technical review request to NF forum. Actually, when this document is adopted last year, we informed the working group adoption to NF forum, and then this year on May, we requested for technical review to NF forum because there's no liaison process between NF forum and IETF, unfortunately. So I just request by email. The issue was two. One is IID generation, and the other one is empty extension in link layer. And then after that, there was a board of directors meeting of NF forum. They said to me there will be conference call or face-to-face meeting for the review. But there was not yet. So, and then after that, the NF forum, the member meeting, but actually it's not member, so we couldn't attend their meeting, but we surely have a conference call like that for the corporation for review, technical review. And then the last week, we requested again the discussion result of the comment, but there's no response so far, and still waiting. If there are some comments from NF forum, maybe we will update to our final version of the draft. So I think we would like to ask the working group last call this time. Any questions?
Gabriel Montenegro, I have a question. You indicated two test cases failed or were not executed. I'm not sure which is the case here. So do you have any further information on what happened with those two cases? What might have failed or what was the problem?
Actually, Mr. Hong will answer for your question.
Okay, so in the second HC flow test, there are 12 the test description regarding NFC. So 10 test cases are passed and 2 test case we don't because two tests there are some precondition, but we don't set the precondition. So we due to lack of time in this time we don't. So we hope to next time we will start that precondition and we try to test the remaining test description.
So it was a test setup issue more than a spec issue, or was?
Actually, I think that the test setup issue, not the specification issue.
Any other comments for Young-Hoon? Actually, in order to go for the last call, we would like to have at least one reviewer, preferably 2, to review this document for completeness and provide comments to the authors. Can we get volunteers to review these documents? If you are interested, can you raise your hands if you are interested in reviewing and giving comments to the authors of a 6-law NFC document? Okay, so please come to 6-law chairs. Otherwise, who is this? Dave volunteer. Sorry, I didn't see that. Okay, thank you, Dave. We need one more person, but please contact us.
Yeah, I would also really like to hear back from NFC Forum. And I understand you've been after that and it's on their table right now.
Okay, my name is Yong-Gun Hong from ETRI. I present the 6-law use case document. Okay, this is the history. You know, this issue was handled in the IETF 89 meeting. So in the Yokohama meeting, we present, and then the last meeting, we also present in the Jerome version. So in this year, May, we have a teleconference, and we have a productive discussion, and now we update 02 version. So in this version, the change of the title and addition of the use case of 6TC by Thomas and editorial update from Rashid Shanghi. And this is the summary of the comment in IETF 95 meeting. So you see that this document should provide some useful information, not only the inside of IETF, but also the outside of the IETF. So to do this, there are some comments for Pascal, Dominic, Samira, Gabriel, Pascal, and you can see. And yeah, so we need a more deployment perspective text. So that's the comment. And in the 6-law mailing list, we got also the valuable comment, Richardson, Samira, Sandra, Carlos, and we got a valuable comment from Rashid Sanghi from the detailed document. So thanks for all. And in the May 19th, we have a teleconference regarding the comment. So at that time, the attendees is Samira, me, Thomas, Gomez, Yongwang, Rashid, Sadi, Daniel. So at that time, we have some conclusion to change the title. For example, IPv6 of constraint neural networks, applicability, and use cases. And also we describe something. And the comment was that this document maybe better go to informational RFC, and this document must target IETF internal working group and also the external SDO. And yeah, so in this document also handled the LPWAN. So at that time we think that it is better to wait until the LPWAN both in this meeting. And the security issue, so should we consider each use cases or the security issue in general? So must decide which one is the better. So in this document, there are 7 link layer technologies, and there are lots of the design parameters for 6-row use cases. So until now, we have the 5 typical use cases. For example, G-Wave, it describes the smart home, and in the case of the BLE, it describes the smartphone-based interaction with the constraint device. And in the case of that BLE, we describe smart home, and in case of the NFC, we describe the alternative secure transfer. And in case of the LTMTC, we describe the LoRa gateway. So in this meeting, we update the change of the title. Previously, the title was that use cases for 6-row, but in this document, we changed the title 6-row applicability and use cases. And so we update the abstract and introduction part, and we add some another link layer technology, the 82.15.4x by Thomas, and the editorial update by comment from Rashid Sangvi. But are there any? There are some the remaining items. For example, the MSTP use cases. So I believe the Kerry will provide the text sooner, and the 6-ish also will be provided by Thomas, I hope. Yeah, thank you. And we must fill a section of 6-row deployment scenarios. So we are seeking valuable content. We are also waiting for the contribution. And we are also decide the LPWAN as a use case in the document. So we maybe the decision, the LPWAN book. And we must decide the security consideration for each use cases or in general. So, okay. So next step. So I think that there are many interests in this working group, and there are many members involved in this work. So I'm asking, is it ready for working group adoption for the next work? That's all.
So we have been discussing this document for a few IETFs now, and the reason we want to write up this document so that our goal is to provide other users, meaning 6-low, outside 6-low working group and outside IETF. The idea that how they can take a 6-low stack and run on their layer 2 networks or layer 2 devices. So basically the applicability on many different technologies and some example of deployment. And we think it might be useful for other IoT areas as they are considering running IP on that. So any objections for adopting this document? Of course, we will go to the mailing list, but any objection? How many people have read this document? Okay, so quite a number of folks. Thank you. So we will take the question to the mailing list. Rashid.
Hello, everyone. So, like, my draft is in 01 version, but the first time I'm presenting here. The name is Rashid Sanghi from Huawei, Rashid Sanghi. So, the draft is designating 6 LBR for IID assignment. So, it is basically in the 01 version. So, we are co-author with Mac Chen and Charles Perkin from Huawei as well. So the purpose is like we have a heterogeneous nature of LLM devices, use numerous methods to generate IIDs. We are quite often talking about the IIDs. So if we use like arbitrary use of IID to attain better privacy, so it would be a better idea. As we got some comment from that corner also, they was also talking about that. So if we designate 6 LBR to suggest a unique IID to avoid repeated DAD cycle for failed DAD, it would be a great idea. So using semantically opaque IID generation is a best idea. 7217 by Fernando is one of the RFC which is quoted in this draft. We have some different categories that to avoid duplication, we have some kind of like ways to generate the IID for privacy as well as the security also. So the history and status of this draft is in the first version, the 0 version. We recommended the RFC 7217 to generate the IID by the 6 LBR because we want to avoid the DAD failure. In case the DAD is failed, then the 6 LBR is going to generate by using the 7217 RFC. So in the second version, we emphasize on a space efficient manner to deliver that generated IID back to the 6LN. So this is the 7217 RFC in which you can see that like 6 LBR can use its own local variable, which is DAD counter and the secret key, but the remaining 3 variables can be like used, which are global. So it is supposed to get the 64-bit IID and then send it back to the 6LN. So this is this is a space efficient manner in which the 6 LBR is supposed to send it back to the 6LN. Here, when the ARO along with the SLLAO is sent to the 6LR in NS, so the 6LR is going to use the reserve bits, like 4 bits, which can give us 16 times like concurrency, and it sends to 6 LBR. So what is the modification? Make use of 4 bits and elided 64-bit prefix over here or on the top. So as soon as the 6 LBR find it out that there is a duplicate address, as the duplicate address is detected, then the 6 LBR is going to generate using the 7217 RFC the IID, and it sends it back to the 6LR. Now that 6LR already have the status that which IID is being sent back, so 6LR is going to extract it, and what we are using over here is the aggregation, the XOR aggregation. At last, the 6LR is going to send back the suggested IID back to the 6LN after extracting it. Here also we suggested IID, suggested IID is XOR aggregated with EUI64. What are the advantages? We are like negating the need to repeated cycle in case of failed DAD, semantically opaque IID, which is a 7217 RFC, and a space efficient way to deliver IID is suggested over here, avoiding an expensive mechanism of DHCP as per our understanding for same purpose. So as mentioned by Dave in his draft, So this draft suggests the IID, which is with 64-bit of entropy, more privacy. So what is the next step? Incorporating the improvements as per the already available comments on mailing list. Thank you by Mr. Hong to provide valuable comments. So in addition to that, there is another draft, predictable numeric by Fernando. We are supposed to incorporate that as well. Thank you, and comments.
Kerry Lynn, Verizon Labs. Given the earlier discussion about the main need for 64-bit randomized IIDs mainly being required for routable addresses, and I apologize, I haven't read your draft, but I'm just wondering, do you compare this technique to, say, DHCP for distributing addresses?
Mm-hmm. Actually, like in the DHC working group, I was watching the mailing list. There was a very, how to say, quite often there was a discussion for that. And there are some reasons that the RFC 7217 cannot be used for using in DHCP and delivering the address to the end node. So that's why I just compared the DHCP could not be a right choice if we are using the 7217.
Lorenzo Culidi, I don't really understand how this is supposed to work. I think, correct me if I'm wrong, I think what's happening is you're forming a UI64 IID, and then if there's a collision, you're delegating formation of a 7217 IID to some other entity. Is that correct?
That's right, that's right. We are talking about like quite huge number of nodes, if the network is quite huge, and then if there is a possibility that there is a collision, the probability exists, although it is very less. So in that case, the 7217 RFC, using the 7217 RFC, the 6LBR is going to suggest IID back to the 6LN.
So basically you're saying that you must have a duplicate link layer address identifier, right?
That's correct. At the beginning, like the first communication is going to be done by EUI 64.
So you want to design for duplicate link layer identifier?
Actually, today I got some, as per my understanding, today I got some positive idea that link layer addresses, as before the discussion was there, so could also be used in the same way. Like duplication may exist, and we can use the same kind of approach to do something about the link layer addresses. But this one right now is for the routable addresses.
All right, so then I have a few questions. Like number one is, what makes you think that RFC 7217 is going to be better at avoiding collisions?
Basically, it gave a opaque and a very balanced like IID generation, and it is quite often been discussed.
Can you go back to the algorithm slide where you have how 7217 works?
Over here.
So what are you going to use for net iFace?
Come again, please.
What are you going to use for the net iFace parameter?
The UI64.
Then it's guaranteed to be the same. Like if you pick the same UI64, this algorithm will give you the same result.
As per my understanding, if there is a collision, then the DAD counter, which has been maintained in the 6LBR, is going to get rid of that situation. And we have a secret key also, which is going to give certain kind of randomization. So at last, we are not supposed to get the same IID. If there is some collusion.
But the secret key is what? It's the same for all the nodes, right?
No. 6LBR would have its own secret key.
Right.
Not for
How
all.
does it know which key to use?
Mm-hmm.
Okay, so can you go back to the diagram with all the nodes, the blue squares?
This one.
Right. So who has the secret key?
Actually, right now we suppose that only the 6LBR have the secret key, and the rest of the node have different secret key. But you're like, as you also mentioned, that like all the nodes would share the same secret key. That is also possible.
No, but like if the algorithm is running on the 6LBR, right? And it has the same, then there's one secret key. It's the same for all the nodes.
If we suppose this is right, like if we say, okay, like 6LBR have the secret key, but there is another parameter, which is the DAD counter, which just keep on increasing in case there is a collision, and 6LBR is going to change it like +1, +1, +1. The entire like algorithm is going to give us another IID.
So basically you want, the only thing okay, so how's this better than a random IID?
A random IID.
Yeah, just form a random.
Actually, like if the same 6LN is traveling to another, like we are talking about the backbone router also. If one network have like multiple segments, like multiple 6LBR, at the time if the 6LN is traveling from one 6LBR to another one, at the time the address is going to be same network wide.
So the LBR is going to have to do DAD, right? If there's something else on the link, it's going to have to send a DAD packet.
Come again, please?
I mean, unless there's only one of those per subnet. I don't know what the model is. Is there only one LBR per subnet?
At this moment, yes.
Yeah.
At this moment.
Okay, so then that one is authoritative on all the addresses on link. Yeah?
Only one, yes. At this moment.
It knows about all the addresses on the link. So in that case, can you just have the nodes compute a random IID, and that's got 64 bits of entropy, which is much better than the MAC address. And then basically, if in the IRO, you can just add a protocol to the IRO to say, sorry, this address is already in use. Because otherwise here you've got like more frequent collisions, and it seems more complicated. Well, you're basically relying on the DAD counter. You basically run the algorithm 2 times, 3 times, whatever, if there's a collision. But you might as well not have the EUI64 address at all, right? Why would you have the EUI64 address if you do this?
Actually, this is a very nice suggestion that like the 6LN is, should start with the 7217 and then ask for DAD. And ultimately, if there is a collision, if there is a probability for that, then the 6LBR should also suggest one.
Wait, if you're willing to do DAD on the 6LN, then just do DAD. Just start with 7217 and do DAD. Because it's really cheap, right? Because it will only happen like once every whatever bits of collision you have. So this just seems super complicated. And so why can't, I guess the question is, why can't you run 7217 on the LN?
LN, actually, I'll come up with the answer in the mailing list or personally to you. That's a very valid question. I'd come up with the answer.
Yeah, maybe you can work with Lorenzo and see, take his suggestion or come up with a better algorithm. Because it seems like, as a co-author of the RC 6775, I remember that we had one gap in the solution when we are working. We have been asked, and we have all the co-authors present in this meeting today, that what happens if you have a collision. And at the time, we did not address that problem. So I could see there is a problem space here, but as it is discussed and Lorenzo suggested, I think the algorithm may not be the ideal one, so that needs to be discussed and solidified. But I see the problem space is here, but I would like to invite comments from the other co-authors of RFC 6775 if they have any comments.
It would be highly appreciated for the comments with it on the mailing list.
Yeah, I think this whole thing should start from very clear motivation, looking at the possibility of collision. Depending on how likely, and I suppose it's not very likely at all, but we should have curves and birthday paradox discussions and whatever. So we will look at those, and based on those, maybe it's a problem we don't really need to, add too much complexity for. But I think it should all start from how serious is the problem. If it's not very serious, then deal with it in the most simplified manner possible without adding more machinery into the protocol. If it's a real problem, then okay, yeah, we should look at it. But I think that's the main motivation. Do we really have a problem here to solve, a real practical problem? That is the main motivation, I think.
Okay, so we would be working on like defining the more like on the problem statement.
How often do you have a collision?
Yes.
And so that's not a one answer, that's going to be a curve. We should just look at what are those curves.
And there is another thing, like this won't be a default like way to resolve it. Like it could be only like one way. Like there could be some other ways to resolve this thing as well. But we would work on the problem statement. Any other question?
Okay, thank you.
Thank you.
Yeah, so please follow up with the comments and try to work on the comments. Daniel, are you there?
So the ITSP flexible and wide range security protocol is what I'm going to present today. Next slide. So the current de facto IoT security protocol is currently DTLS. It's perfectly fine for web-based, IoT web-based applications, and most probably for an end-to-end security. But we don't think it addresses all the IoT scenarios. So in this presentation, we're going to show that end-to-end security comes into IoT deployments with some drawbacks. ESP, IPsec can address some of these drawbacks. And because the ESP is useful for IoT, then we were wondering if we could design an IPsec ESP that really fits IoT needs. And that's going to be called the ITSP. Next slide. So end-to-end security is basically in each sensor, you have a TLS session between the sensor and the destination service. This first comes with some privacy issues because an outsider can observe the IP address, source, destination, the port, so that is the application, as well as the frequency the data is being sent. So think of a healthcare sensor. In that case, it can be just observing the traffic, even though it's encrypted. We can't really derive the disease the person is affected. It also comes with, oh, yeah, this slide. So the healthcare sensor can't, so it also comes with some management issues. Think of a sensor that is configured once for all. It's going to send data to the same cloud or applications. The data owner has absolutely no control on which data has to be sent and whose cloud provider it's going to be sent, so the destination. In other words, if he wants to change, the application is not able to. And it also comes with some scalability issues. We're not thinking about 5 sensors, but we're thinking of millions of sensors that are establishing a session to the destination point. It's really very close to a distributed denial of service scenario. So next slide, next slide, next slide. I'm just going to present some insight about how IPsec can address some of these issues. Well, next slide. So the basic thing is that with IPsec, we are able to define some secure domain. And communication can be done between domains. So in this case, we only have one secure tunnel between the 2 domains. The tunnel is encrypted, so any data that is being tunneled is not seen by an outsider. So no IP from the sensor, no IP for the destination, and no indication about the port. It also provides the ability for the data owner to manage the data within the secure domain and to change the destinations if he wants to. The secure domain, well, we can use link radio security, radio link layer. In that case, we don't really need to have an additional security protocol on the top. And if you need to extend this secure domain, then you can't really build a VPN. So in this example, with a person who has a VPN with ITSP. Next slide. So we really think there are significant scenarios where IPsec ESP complements DTLS and DICE. So let's go a little bit deeper into the interesting features that ESP can provide. Next slide. So we already talked about privacy and security. So ESP protects the transport layer, avoid the IP addresses to be revealed, the ports, and so on. But it's also very flexible because ESP can work with any key exchange protocol. So it can work with IP2, can work with a DEX, it can work with GDOI if you're using multicast, or any proprietary or architecture-dependent key exchange protocol. Next slide. It's very scalable because it provides these domain-to-domain communications, secure communications. It's also enable multicast. Multicast is just built in, so just use it. And it enables the reuse of the know-how of infrastructure deployment. After all, mobile networks are already deploying millions of devices. Other advantages are that it provides a very good integration with the radio layer because 15.4 is using to a key exchange protocol that is IP2 or DEX. So why not reusing this, this implementation that are embedded into the chips, the radio chips? And interoperability, there is only one version. Whatever the transport mode is only ESP. So next slide. So since ESP is useful for IoT, now can we improve ESP and make it even better for IoT? So this is a version what we call DITE ESP. So DITE ESP is really built out of ESP and ROC for the compression. We defined ROC-like profiles, a ROC-like compressor, and we don't touch about the encrypted data. So in that sense, we are not weakening the security. And compression has been already made for years with ROC. But the difference with DITE ESP is that not only we compress the ESP header, but we also compress the ESP trailer. So next slide. But let's look a little bit more about what we can gain about using DITE ESP in terms of networking overhead. So I'm taking the example of AES CCM with an ICV of 8 bytes. So currently with the DTLS, it's 29 bytes of overhead. If you use standard ESP, it's 20 bytes. And if you use DITE ESP, you can go from 8 to 20. 8 is just the size of the ICV, and 20 is the same as ESP. So we remain compatible to ESP. When you look at the size of the radio frames, it means that simply considering the overhead, at some point, you might need 3 times, well, you can reduce by 3 the number of radio frame you need, which means somehow that the device can sometimes live 3 times longer. Next slide. So where we are with DITE ESP. So we currently have 2 drafts. One is defining the requirements, and the other one, which is defining DITE ESP. We have an implementation working on Kentucky. We hope we can have soon one working on Riot. And well, it took us for a few days to adapt DITE ESP from ESP. So DITE ESP is between IPsec protocols and 6LoW. So we had discussions with the chairs. The former chairs of IPsec prefer that to be hosted in 6LoW. And why 6LoW? It's because it works with any layer 2 that supports the 6LoW stack. It provides network level security for all data between gateway, between the host nodes, for all application and control data. And it's required for ICE security IoT deployments. So the next step, now I would say, is, next slide. I would like to see if there is interest in this working group to work on, that we go on with this work on the ITSP. And thank you for the presentation. Next slide.
So how many people have read this document? Okay, so do you think this document is interesting for 6-Law working group? Okay. Gabriel has some comments.
Yeah, I mean, I don't see IPsec. Anyway, I'm having trouble with the motivation about end-to-end security versus the VPN approach. I mean, TLS has basically eaten IPsec's lunch in VPN. We know that. So VPN is actually more amenable to TLS than to IPsec itself in the real world. So that's not a limitation there. But I guess my main question would be, I would challenge what the IPsec group said. This is not a security group here. This design may have a lot of security implications, and we're not the crowd to do that. I would much rather this be done there. If there's interest here, we would ask the IPsec working group, hey, 6-Law needs this work to be done, do it there, or do it in security area somewhere. But doing it here might not be the right place, because it needs a lot of security eyeballs to review it, which we may not.
Yeah, so just to answer, well, having this work here does not mean I'm not gonna present it into IPsec ME. Actually, we received a lot of
Or
feedback.
vice versa, but what I'm saying is they said we should own it. No, I think they should own it, and we'll review that. That's how I would think it would go.
Well, the thing is that, well, whoever is hosting the work, I mean, the both community is going to be involved into that. So it's not something that we're going to do only in one community. And the other thing is that most of the questions, I think, are mostly related to the compression aspect, because I think we already got a lot of review from IPsec ME folks. And I mean, it might be changed because the working group chairs have changed in IPsec ME, but the decision was from them. Their view was that this work should be hosted here.
Okay, Suresh Krishnan. So one thing, Gabe, is that it really doesn't matter where it's done. So like leave it up to you chairs to figure it out. But we can do a joint working group last call at both the working groups if this work is taken up. But my understanding of like the stuff from IPsec ME is that like they need like some kind of justification to do this work if it has to go there. So and that needs to come from like 6-Law. So I think that's the point. So like if we figure out this work needs to get done, we'll figure out the logistics, whether it's going to be like working group document in one place or another. In either case, it needs to go through working class column.
Carrie Lynn, yeah, just to follow up on that, I think as a general matter, there are several areas of overlap with other working groups or areas where we really have the motivation to solve the problem, but how do we get them involved? I think really, I think most of the people who'd be interested in working on this are probably sitting in this room. Hopefully, they also sit in the SEC working groups as well. But this is not a problem specific to security.
Juan Carlos Zúñiga, Sigfox. Yeah, I agree that this is an interesting problem, and I want to support the fact that, as Daniel mentioned, that this is mainly related to the compression and fitting into the constraints. So definitely we need the expert eyes of security guys into this, but I mean, it's all logistics. It could be either side, but my preference would be to handle it here and then get it reviewed by them over there.
Brian Wise, Cisco. Yeah, I like the idea of the super small compression compared to some of the other approaches. So I think this should go forward. I don't really care which group it goes in.
Samita Chakrabarti, just without the chair hat. I think we need multiple level of security solutions for the IoT. We do have like TLS and application level solutions, but imagine like thousands or hundreds of IoT gateways connecting to other next level gateways. And today, if we have, we don't have any network level solution with right compression. So I think the problem space is interesting to me as well. And handling it, if working group is interested, I guess we could look into the next step, probably joint work with IPsec.
Yeah, sure.
But we'll leave it to the ADs to decide.
Yeah, that's, I mean, for me, it's the same because I'm presenting the work in both working group anyway. So, and the IPsec chair is there. So.
Thank you.
Well, thank you.
Okay, so who's next? Youngjun, would you like to give an update on the plug test?
Okay, this is the report of the 6-row plug test, which was held in the last Friday and Sunday. Okay, so the plug test was hosted by the Edge, and the supporting company is the OpenMode. And in this plug test, it's a joint plug test, the 6-pitch and the 6-row. So there are the 15 participant companies. Okay, so among them, for the regarding 6-row, the number 6 to number 10, the 5 company are related to the 6-row. So, and the A3 and their reflection and TGI Uniforman are the NFC, and others the 7, 8, 9 are IEEE, the 15.4. Okay, this is the agenda. So as you can see, there are 3 days. So 2 weeks before, we have the teleconference for the plug test. And for the test description, for the regarding 6-row, the Carsten and the Kerry have done. So thanks to them to have this good document. Okay, this is the picture. You can see there are many laptops and there are many lines. It's kind of chaos, and there are many drinks around the test bed. Okay. So to report the test result, we use the Edge test report tool, TRT. So it is kind of efficient. And so I think that the 6-pitch result will be handled in the afternoon session. So in this time, I would like to focus on the 6-row. So as the Dr. Choi said that we have tested the 6-row NFC. So in this time, we passed the more than 800% interoperability. So if we look at say more detailedly, there are 3 companies of the regarding NFC, A3, their reflection, and TGI Uniforman. But unfortunately, the TGI Uniforman don't test because of some issue. And the 6-row ARIO 15.4 cases, there are some issue of the frequency. So in this time, we don't test. So this is the recommendation for future. So if we think that it's more better to have the 6-row gateway because in a 6-row link-array technology there are lots of, for example, BLE, NFC, and G-Wave, MSTP, backnet. So it's more better from the common 6-row gateway. And the other thing is that if we test and if we interoperability, we need more the kind of the packet sniffing mechanism. So in this time, we use TCP dump and the wire sock, but sometimes it makes some problem because the Intel Edison board and some of the laptop, it is kind of the constrained device. So in the next time, we plan to kind of the packet capturing device, for example, using the serial interface. So I hope so. It will bring the next time. Okay, this is the picture of all the participant. So that's all.
Thank you. So next I believe is Pascal. Pascal, are you there? You don't have any slide on LP1, so we'll just talk about it. Okay. Okay, so we don't have the slides. We can.
No, he's just going to talk.
Oh, he's going to talk about it.
Okay, so there's a long history since we published 6LoWND about updating it. There was a RFC 6775 update draft, which is expired, but which gives us a list of things which are desirable from a number of angles, including coming from 6-dish. There was the efficient ND draft, which was proposed at 6-man to generalize the approach to any low-power device connected to any infrastructure, which is expired as well. Then the work was kind of merged into the backbone router. And as we discussed earlier, we now are splitting this work out of the backbone router to make it a specific RFC 6775 update draft. So out of the problems or the requirements listed in 6775 update, this draft covers all the primes but the ones linked to security. And there is another draft at 6LoW which deals with the security aspects of it. The text which is in this draft that is extracted from the backbone router, as I said earlier, is not yet extracted from the backbone router, pending adoption of this work. So there are really two pieces in this draft. One enables the in a ripple network, when you've got a mesh, the device itself does not talk to the backbone router to enable the registration. You rely on the root of the ripple network to do the registration on behalf of the end device. So that's why there is this major change from RFC 6775, that it's not the source address of the NS arrow that is used to register, it's now the target, so that the 6LBR can actually register on behalf of the 6LoWPAN node. The other major change is that we have incorporated a sequence number, and that sequence number enables to follow, to track a device as it moves from one 6LBR to the other 6LBR. We know which is the freshest location of the device, and this way we can make sure that the packets get to the right 6LBR across the backbone. So these are the two major changes from 6775. Now, versus the 6BBR draft, a good bunch of the text, as I said, is just copied from the 6BBR, how the arrow option is being extended, how the sequence counter is being done, etc. There is new text. There is text which is in this personal submission, but is not in the 6BBR. It's all the text which describes the link model. Because part of the problem we have is a chicken and an egg between forming a link local address, allowing this link local address to register to the 6LR, and then checking if this link local address is unique over the network. We actually, in RFC 6775, we actually validate if a link local is globally unique over a subnet, which is not necessarily useful, because the only thing you really need is that between the 6LN and the 6LR, this address can be used and seen as unique. So the link is really my device with the 6LR. If the 6LR did not see this link local address before, then that's okay, it's unique. There is no point in going to a 6LBR to check that. It's unique in this link, which is a point-to-point link between the device and the 6LR. As long as we don't use the link local for anything else, there is no point in doing any more validation. So one of the changes or the refinement or more precision that this draft is giving, it's saying for the purpose of uniqueness of a link local address, the link is the device to 6LR. Now for the global addresses, then you need the 6LBR because it has to be globally unique, and that starts with being unique across the subnet, and that's what the 6LBR will check for you. Okay, so that really simplifies the way you form your addresses, because when you talk to the 6LR can, on a link local, can answer immediately, yes, that's okay, just pick your link local, and now I know you, and we'll talk with this link local. And once you've done that pass, then you can go and register the global addresses, but you know you have an interface with a 6LR that you can use.
Zach Shelby, ARM. I'm a bit confused. So why exactly are you solving this problem when this has nothing to do with backbone router stuff?
No, it has nothing to do with backbone router. It's added to this thing and not extracted from the 6 backbone router. The goal is to avoid this chicken and egg problem of using a link local address with your 6LR, and you don't know yet if it's unique, and so there is a window of time where the 6LR has to go to the 6LBR to check if this address is unique. It has to put it in some special place because there may be a duplication and it can't store it. It's in its neighbor cache before the 6LBR has said, yes, it's okay. But if you look at it, this link local address does not really need to be unique across the whole subnet because it is a multi-link subnet. Right? So there's no point in having this uniqueness across the multi-link subnet. So the question is really, what is your link? And when we discussed that earlier, we figured that the link was probably whatever my radio can reach. Yeah. But that's really weird because sometimes you can reach some people and some other times you can reach other people. And so at the end of the day, you figure, oh, why do I need this link local for? I need an address that I can use readily to talk to my 6LR. So as long as this 6LR did not see this link local address, then he can associate it to me and we can talk. And that's enough. And so for that purpose, considering that the link is really me and my 6LR, now we don't need to go to the 6LBR. We have an address that we can readily accept or deny without going anywhere else, without populating a table on the side to keep it, yes, it's not yet an indication tree, it's pending some validation. Right? So the discussion now between the 6LoWPAN node and the 6LR can happen. Or it's rejected before it even starts. But there is no weird window where you store things apart. And now the 6LR and 6LN can talk. Once they can talk, then the 6LN can go and say, oh, now I have this global address, let's do something. But at least we have a vector through the link local that we can use to talk and say, oh, we go to 6LBR, we come back, etc.
I get the problem you're trying to solve. I would point out that we had a very long discussion about this link model and the fact that these radio networks are changing all the time. So although this link local address may be unique with your 6LR right now, I tell you that group subset of devices that are talking to that particular 6LR will change.
Yes.
And your 6LR will change. So,
and you'll have to check your link local address with every one of them individually. You can use the same link local address with different people because that's different links. And this link local address, so done for me, done to me is a link, me to you is a link. I can try to use the same link local address with both of you, but if it fails with one of you, I will form another one to talk to him. That's what this draft is saying. Because you never know, as things come and go, if it's unique in somebody else's cache, right?
Okay.
So it's actually solving the problem you're talking about.
let's talk about this some more. I think we need some discussion. And
I
I
need-
would suggest you split this up because I think you're making your life difficult here, or you have too much free time.
Well, it's changing the registration flow because now you're not going to the 6 LBR, right? So it's important if we update the draft to put that in the update.
I get that, but the point of this, from my understanding, was to get your 6 BBR related changes for an RC 6775 update. And this is kind of going way beyond that.
This is going beyond, yeah.
So you might want to, just as a working group, we might want to split those. Because the other one doesn't seem controversial at this point. This might be.
Oh,
My
let's
two
check
cents.
if it is controversial. Maybe we can agree on it because we are now. It's no more about it. What you say is true. When it was a single contained document, that's exactly what the goal was. But now we are saying, oh, we're updating 6775. So now the goal has changed, and so the goal may be to do the right thing for 6775. So let's see if this is the right thing or not.
Yeah, Don Sturridge, Silver Spring Networks. So I'm familiar with quite a few adoption organizations. All of them disallow DAD. So I really hope that whatever you're trying to solve here doesn't drag DAD into the solution. And I like a lot of what's in the backbone router.
Disallow, can you be specific?
DAD, the duplicate address.
Oh, they don't use that.
Nope.
Right.
And so what I'm saying is I like a lot of what's in the backbone router draft, but I really hope it doesn't drag DAD into the solution to implement it.
Well, this actually tells you that, well, this doesn't create any additional flow, right?
Well, it says right here, the link local solution that you're talking about point to point now can be validated by DAD, which doesn't exist in most.
So there is no more, I mean, okay, 6LOP and ND is already a DAD. That's what it is. Okay, so the change here is that the 6LR does not need to go to the 6LBR for link local address, but it simplifies what you already have. It doesn't add anything. I mean, the 6LR could already refuse a registration if it has a duplication already today, right?
Yeah, it could do that.
So I'm not changing that. I'm just saying there is no point in going anywhere else.
So there might be terminology question here, which is that, so when we say DAD, do we mean what's in 4861, which is send a multicast packet, or do we mean the general concept that please check whether this address is unique or not? Because this does, please check whether this address is unique or not. It doesn't multicast the packet waiting for anybody to respond. I think that's the term, uses DAD as the generic thing, not the multicast and wait for a second, right?
Right.
You're right. That actually solves my problem.
Okay, thank you, Eric.
Carsten Bormann, current 6LoWPAN implementations usually have a single link local address, but not necessarily a single 6LR. And you're proposing to change that?
Well, I'm actually making more clear what happens in a certain situation. Say, at a certain point of time, I can see only one 6LR, and I do a registration and my address passes. And later, well, we add new devices in it. It's probably linked to yes, I'm probably changing that. The case being that if the network splits and joins and forms, you may not be guaranteed that your link local is global forever. You kind of give a global purpose for link local. Here we say the link local is unique to a conversation with a given device. So yes, a second 6LR may deny that because it already saw this link local address.
So how do 16-bit addresses fit into your picture?
16-bit, you mean when you okay, if you have a address which is derived from 15.4 with the network and the ID, 16-bit ID short address, then it's supposed to be unique because of other mechanism which give you the network ID and the unique address, right? So the collision is not supposed to exist. Now, if it exists, now it's a way to detect it, but.
Yeah, how do you make sure that that collision doesn't exist?
Okay, so you're asking how the IP layer assures that the network, the 15.4
But in
layer.
6LoWPAN, you get the 16-bit address from the LPR.
Well,
Welcome to 6LoWPAN.
you can get it from the LBR. You're getting it from your network coordinator.
The only mechanism we have in 6LoWPAN for that is asking the LBR.
Well, the LBR is the layer 3 concept. The coordinator is the layer 2 concept. So you get your short address from the coordinator. You may implement it in the 6 LBR or not, right?
I don't care about coordinators. I'm talking about 6LoWPAN without beacons and all this stuff.
Okay.
If I need a 16-bit address, I go to the LBR. Yes. I'm using my 64-bit network address to go to the LBR and get a 16-bit address.
Yes, the microphone is not talking well. That's why I have a lot of trouble to get you as well. Let's talk about that on the mailing list. But the point, your initial point being, I may need to have a different, in the very generic case, to have a different link local address to talk to two guys. Yes. So your initial point, the answer is yes. It should not occur if you build your interface ID in a way which is effectively unique, like basing it on a short address which has been given to you some way, and which is effectively unique. So prime will not occur. But if you randomly form your interface ID using anything, it's perfectly fine that you have very little chances of collision if you talk to just a single guy. Now, if you talk to another guy, there may be a collision, and we'll detect it. But then the answer to that prime is, if you want to talk to this other guy, form another link local address. Yes.
So all I was trying to point out is that the changes you are proposing have lots of impacts on various parts of the architecture. So it's
but I would not link that to the way the layer 2 works, right? The layer 2 works first, and then the IP comes over it.
Yeah. Manuel Bocelli, INRIA. I haven't read the draft, but now I'm very interested because I really like this kind of stuff to work. I have the same kind of questions that pop in my head as Zach's. It's not obvious to me how this interplays with time-varying aspects and partial overlap of radio ranges of different nodes, of different LRs that might validate something that another LR would not have validated at a different time, and which might create some collisions. So there's a draft that's currently a working group last call in area that talks about like a lot of these problems, like really the base of these problems. And so again, I haven't read your draft, but I think that when I see this, it should definitely reference this draft that's in working group last call. And
let's have on the mailing list, so
yeah,
we expose all these
and
to
actually talk about like, okay, what kind of problems there could be and how these are addressed. And then I think like questions that popped up from Zach or myself or others would be like resolved.
Yes, and that's why this is a personal submission at this time, and maybe we'll get rid of it, maybe we'll keep it. We'll see on the mailing list.
More slides? No.
There's nothing much. Yeah.
Okay. Yeah, so looks like, there are more discussions needed, and I think, if we are calling it like more 67, 75 updates, we need to make sure there is backward compatibilities, right? So, and no architectural major issues. So we need to probably discuss offline and in the mailing list as well. Thanks.
Cool.
Okay, so next is LP1 updates, but I would like to know where are the blue sheets? Anyone needs to update the blue sheets? Please update. Okay, there are some in the back. So you don't have a slide, so just go ahead.
Thanks. So my name is Alexander Pavlov, and I'm going to talk to you very briefly, so there are no slides, about the upcoming LP1 BAF that's going to happen today at 3:40. So as you know, for the past 3 to 5 years, we've been seeing the arrival of new family of technologies, of radio technologies out there that have very, very different characteristics to anything we've been witnessing until now. And these are the family of technologies you may be heard of, such as Sigfox, LoRa, and NB-IoT. So we've been running on mailing list for the past since the IETF in Yokohama, and we had a non-working group, non-forming BOF in Buenos Aires, where we had lots of discussions, and we saw that there are some characteristics that make the things that we have right now a little bit difficult to run on these types of networks. And just to give you an idea, we can have, for example, of MTUs of 12 bytes. And the throughput that you can have is in the order of millibits per day. So these are things that are really, really, really constrained. And what we want to do is we want to bring the IETF stack and IP UDP co-op, so the whole IETF stack and the architecture to these networks. So we've had a technical session that we have a couple of drafts submitted, a lot of discussions out there. So very we see that there is a very interesting dynamic and a lot of things that have been discussed that we've been discussing there. And today we have actually representatives of the 4 major LP1 technologies that will be presenting. So we have people from Sigfox that will present their technology, people from LoRa Alliance, people from NB-IoT, and people from IEEE that will be presenting their technology and stating their specific problems that we would like to solve. So we'll be looking at, of course, what are the existing things that we can take and how we can actually interact with other working groups that exist at the IETF. So please come by. It will be an interesting discussion, very open, and we'd like to see you there and have your input. Thanks. It is LP1 from Low Power Wide Area Network. Thanks.
Thank you, Alex. I think this is the end of this session. Thank you for attending, and we'll see you at IETF 97.
And one last point, if you have minutes you're willing to volunteer, even if you haven't volunteered yet, they're always welcome. Thanks. Yeah.
This time we don't have one SCR. We complain about
I tried to complain. Maybe not as loudly as he did. I don't see the interest. I'm not interested in that at all. I don't see anybody really deploying that. Is there any SDO interest in deploying that? Anybody, or any products in general?
Maybe those are not needed for small, today